If extraterrestrial civilizations really exist, then where are they? Why, in a universe filled with countless stars and planets, have we still found no clear evidence of alien life? Even more strange, according to many scientific estimates, alien civilizations should not only exist, they should have already appeared. So the real question becomes, if they exist, why haven't they come here? Why haven't they left any trace? Why does the universe feel so silent? Welcome to Unmarked Sky. Today, we explore a question that has haunted humanity for over 70 years, the Fermi paradox. At first glance, it's about aliens. But the deeper you go, the more unsettling it becomes. Because this question may not really be about them. It may be about us. More than 2,000 years ago, when humans first looked up at the sky, we believed everything revolved around Earth. That idea lasted for centuries until Nicolaus Copernicus proposed the heliocentric model. Humanity realized for the first time that we are not at the center of the universe. Later, with modern astronomy and tools like the Hubble Space Telescope, we discovered something even more humbling. The sun is not special. The Milky Way is not central, and Earth is just a small planet orbiting an ordinary star. And at that moment, a new question emerged. If the universe is this vast, why haven't we seen anyone else? In 1950, physicist Enrico Fermi asked a simple question: where is everybody? That question became what we now call the Fermi paradox. Its logic is simple. If the universe is so large, intelligent life should be common. But we have no evidence, and that contradiction is the paradox. What makes it truly disturbing is this: it's not science fiction, it's a scientific problem. And even today, there is no agreed answer. Let's look at the scale. The Milky Way contains 100 to 400 billion stars. The observable universe may contain around 700 sextillion stars. And that's only what we can see. If life has even a tiny probability of emerging, then the universe should be full of civilizations. Many stars are also far older than our sun, which means if life developed there, some civilizations could be millions or even billions of years ahead of us. Given enough time, even slow expansion could spread a civilization across an entire galaxy. And yet, we see nothing. That is the true weight of the Fermi paradox. Not whether aliens exist, but why they haven't already appeared. In 1960, astronomer Frank Drake introduced a formula to estimate how many communicative civilizations might exist. The result was wildly uncertain. Depending on assumptions, the number ranges from almost none to hundreds of thousands, which suggests something important. Scientists don't dismiss alien life. Many believe it should exist. So again, why don't we see it? One of the most important answers is known as the Great Filter. The idea is simple. Life does not evolve smoothly. From chemistry to life, from single cells to intelligence, from intelligence to technology, and from technology to interstellar civilization. Each step is a barrier, and somewhere along that path, there may be a filter so difficult that most civilizations never pass it. That is why the universe appears silent, because most civilizations never make it far enough to be seen. The most unsettling part is this: we don't know whether the filter is behind us or ahead of us. If it's behind us, then humanity is incredibly rare. But if it's ahead, then something is waiting, something that most civilizations fail to survive. Nuclear war, runaway AI, ecological collapse, unknown technological risks. In that sense, the Fermi paradox stops being about aliens. It becomes a warning. There's an even darker implication. If one day we discover simple life on Mars or another world, that might be bad news, because it would mean life emerges easily. And if life is common, then civilizations should be everywhere. But they're not, which suggests they don't survive. Of course, The Great Filter is not the only explanation. Another possibility is distance. Even advanced civilizations may be limited by the speed of light. If faster-than-light travel is impossible, civilizations may simply be too far apart to ever meet. The universe wouldn't be empty, just disconnected. Another idea is more unsettling. What if they're already here, but observing us? If humanity discovered a less advanced civilization, we likely wouldn't interfere immediately. We would observe, study. Wait, this is known as the zoo hypothesis. From this perspective, Earth might not be ignored. It might be monitored. There are also more radical ideas. Perhaps alien life doesn't look like us. Perhaps it isn't biological at all. It could exist as energy, as information, or in dimensions beyond our perception. If we are limited to 3 dimensions, we may simply be unable to detect them. In that case, the problem isn't that they're missing. It's that we cannot see them. And then there are the extreme theories. What if Earth is a prison? What if it's an experiment? What if we are being observed, controlled, or even designed? There is no evidence for these ideas, but they persist because the paradox forces us to consider uncomfortable possibilities. And finally, there is one last explanation. What if reality itself isn't real? If a civilization becomes advanced enough, it could simulate entire universes. Consciousness could exist inside a constructed reality. If that's the case, then this universe may not be meant to reveal anything beyond itself. We might not be failing to find aliens. We might be inside a system where finding them is impossible. It sounds extreme, but that's what makes the Fermi paradox so powerful. It begins as a question about aliens and ends as a question about reality. What is life? What is civilization? Why do civilizations disappear? Is this universe the only one? And most importantly, where are we, really? Because in the end, the most disturbing part of the Fermi paradox is not that we don't see them. It's that if they are out there, why do we know nothing? Is it because they don't exist? Or because we are not meant to know? If you're interested in exploring the boundary between science and the unknown, consider subscribing. This is Unmarked Sky, and we'll continue the search